Okay, so hi, I'm Alice from Athena Education. So you can just call me Miss Alice. And this is our pre-IB math trial class. Okay, so for this class, okay, we are going to use two textbooks. They're very standardized textbooks for IB. So we have a grade 7 and a grade 8. It's not going to be quite like your classroom curriculum, obviously. It's going to be, much more advanced, targeting the IB test. Okay, so for today's class, I took material from the 7 textbook, right? Because we want to start off, not right at the most advanced level. Okay, and here is a brief overview of the curriculum. Okay, so mainly for this class, we're going to cover algebra and geometry. Okay, those are the most important math strands, and most of the questions on the IB entrance test are going to be algebra and geometry. Okay, so some of the things we'll cover under algebra will be number sense, percentage, fractions and decimals, powers and radicals, solving equations, algebraic factorization, and simultaneous equations. For geometry, we have angles, lines, and parallelism, transformations, similarity, and congruence, geometry of polygons, length and area, volume and capacity, coordinate geometry. Okay, so don't panic if you feel like, oh, this is a lot, or if you feel like, oh, I already know most of these. Okay, so we're not, this is just like the overview of the curriculum, right? Some of the concepts we're going to cover in more detail than the other ones, but you can just get a general idea of what we're going to go over. And then some other strands not related to algebra and geometry are graphs, sets, probability, and trigonometry. Okay, and again, we might not cover every single one of these. Okay, but this is just like what you can expect from the curriculum, because I want to do the best job I can to prepare you guys for the test. Okay, then, and for the textbooks, right, we will send you the PDFs for the textbooks. Okay, so you will have the material with you, just like if you're in school, they would send you the textbook. Okay, so you're gonna have that going forward. And then, okay, let's start off with an opening problem from chapter 1, whole numbers, right? So this is from the grade 7 textbook, as I mentioned. Okay, so can I get somebody to help me read the question? Anybody? Raise your hand. You guys are so quiet today. How about you? How about Jerry? Does your microphone work?
Yeah, it works.
Yeah, can you help me read the question, please?
A 16-story hotel with floors G, 1, 2, 3, all the way to 15, has no accommodation on the ground floor. On the even-numbered floors 2, 4, 6, there are 28 guest rooms. On the odd-numbered floors, there are 25 guest rooms. Room cleaners work for 4 hours each day, during which time each cleaner can clean 12 guest rooms. Each cleaner is paid at a rate of 16 euros per hour. Consider the following questions. How many floors are odd-numbered? In total, how many guest rooms are on all the odd-numbered floors? If each guest room has 3 chairs, how many chairs are on each even-numbered floor? How many guest rooms are in the hotel? How many cleaners are required to clean all guest rooms, assuming the hotel was full the previous night? What is the total cost of hiring the cleaners to clean the guest rooms of the hotel?
Great, thank you, Jerry. Okay, so does anybody have any questions about this problem so far? No? Okay, so let's move on to the questions then. Okay, so the first question is, how many floors are odd numbered? Okay, so I'm just gonna go back to the slide so you have the question. Okay, how many floors? Who wants to give a shot at this question? Eric? Okay, great, thank you. So
15.
15. Okay, so look at the question again. How many floors are odd numbered, right? What does odd numbered mean? What's an odd number?
How do I say this?
Let's see. Okay, sorry, who read? And Anthony, you raised your hand. What did you want to say? Sorry, I can't hear you. Are you talking?
Any number not divisible by 2. Can you hear me?
Not really. Is your mic? Are you far from your microphone? Is your microphone kind of weak? Okay. Okay, sorry, I can't hear you. Jerry, also raised your hand. What did you want to say?
I think there are 8 floors that are odd numbered.
Okay, let me just. Good. And how did you get that?
There's 2 ways you could get this. You could either count all of the odd numbers up to 15, or you could divide 15 by 2, and you'll get 7.5. But since you start with an odd number, I would say that there are 8, because if you split it in half, there are 7 and 8. So because you start with an odd number, there's 8.
Okay, that's great. Yeah. Okay. And Anthony said in the chat, any number not divisible by 2. Yes. Good. Great. Okay. Great job. That is correct. So there are 8 floors. Great. And yeah, you're right. There were 2 solutions. So I just listed this one. It was this one, the simpler one, to list them out. But then also, okay, note that I have this symbol over here. So in case you guys haven't seen that before, that means therefore, okay? So you should always have a therefore statement at the end of word problems, and it must be in the form of a complete sentence, right? So make sure even for a really simple question like this, you wanna show your work, and then you wanna write your therefore statement. Okay, so 8 floors are unnumbered. Very good. Now let's look at question 2. Okay, so in total, how many guest rooms are on all the odd numbered floors? Okay, I'm just gonna go back to the problem, so you have the original information as well. Okay, so since Jerry already answered and Anthony took a shot as well, so can somebody else try to answer question B? How about wait, where did she go? Okay, how about Megan? Do you want to give it a shot?
No, I don't want to.
Why not? All right, maybe you're a little shy. How about Lyria? Lyria, are you here?
Yeah, I'm here.
Can you try answering B?
Sure.
Okay, so in total, how many guest rooms are on all the odd number floors? No, you're not sure?
Not sure yet.
Okay, well, let's look at what information we need to identify to answer this question, right? So from the question itself, okay, what information do you think is relevant to help us answer how many guest rooms are on all the odd number floors? So look at the question, right? These first 2 paragraphs. Okay, what information do they give us here that can help me answer that question? Anybody else have any idea? You can raise your hand if your camera's on, or you can use the raise your hand function. Okay, Eric, what are you thinking?
I think it says there are 25 guest rooms on each odd numbered floor, and we know that there are 8 odd numbered floors. So 25 times 8 is, I am pretty sure, 200.
That's great. Good job. Exactly. Okay. So guys, when you have very good job. So when you have multi-step questions, right, you have to, don't be daunted by it. identify how you can break it into smaller steps and how you can use information that you already have, whether from the question itself or from a previous answer, to get the answer. Okay, so from a previous answer, right, we know, just like Eric said, odd number floors are 25 guest rooms per floor. And we know from question 1, there are 8, right? So 25 times 8 is 200. Okay, so good job. Even better that you got, you calculated that mentally, so very good. Okay, let's look at question 3. Okay, if each guest room has 3 chairs, how many chairs are on each even numbered floor? Okay, so just gonna go back to the question. Okay. Anthony, does your mic work now?
You can hear me, right?
Ah, yes, much better. Okay.
Okay, so question number C, it's 588.
588?
Yes.
Oh, okay, how did you get 588?
So then because there's 7 okay, so 7 even levels, like for like hotels, like for the guest rooms, and on each level is 28. So I did 7 times 28, and then but then in each guest room there's 3. Wait, no.
So,
Yes, and then that times 3 is
So just
588.
okay, so just you have a very good thought process, but just be careful because look at the question again. It says how many chairs are on each even numbered floor, right? So does each mean the same thing as all of the floors, or does it mean one floor?
Oh, give me a second.
Okay, Jerry, what did you want to say?
I think that there is 84 chairs on each even numbered floor.
Okay, so you're saying 84. Okay, and where does 84 come from?
So there is 28 guest rooms per even numbered floor, and each of those rooms has 3 chairs, so that's 28 times 3, which is 84.
Great. Yes. Okay. So, and then I see Anthony agrees. So yeah, be very careful, right? Because just that one word difference, right? Each versus all, it drastically changes the meaning of the question. So please be careful with that. And yes, so right, we have, this is what I got as well, 84. Okay, great. So let's look at question 4. How many guest rooms are in the hotel? And again, when you have, one question and there's like A, B, C, D, E, F, right? Or even just A, B, C, you'll often use information from previous questions to answer the next question. So it's important to keep track. Oh, it's a little harder for you guys because it's my PowerPoint, and you may not have this written down, right? So in the future, during class, make sure, even though this is an online class, right, make sure you have a notebook or a piece of paper and you're writing it down, okay? And those notes are for your own reference as well. Okay, so any ideas? How many guest rooms are there in the hotel? Okay, Anthony?
396.
Okay, I'm gonna just come to this. Okay, can you just walk me through how you got to that answer?
Oh, sorry, I was mute. So I just did 8 times 25. Then I did.
Okay, where does the 8 come from? Where does the 25 come from?
Because there's 8 odd levels, and each odd level has 25 rooms.
So we already know from a previous question
and then that's 200
rooms on odd number floors, right?
Then I did the 7 times 28, which is 7 even number rooms. rooms plus
Seven even numbered, sorry, 7 even number rooms?
No, levels, sorry.
It's okay. 7 even numbered
Even-
floors. And how did you get that? Because that was
and then there are 28 rooms on each of those floors.
Okay, hold on a second. How did you get, yes, there are. How did you get the 7 from even numbered floors?
Because because the amount of even numbers in 15 is 7. Wait, it's not. Wait. Give me 2, 4, 6, 8, 10, 12, 1, 4. Yeah, 7, is it?
It is 7, yeah. I just wanted you to explain how you got it in case, other students are like, where did the 7 come from? Just pull it out of his mind. Okay, so there were 2 ways to get it, right? So you could have well, actually more than that, but you could have counted from 2, 4 to 14, right? That would give me 7 even numbers, okay? Or we already know there are 16 floors in total minus 1 ground floor minus the 8 odd floors, right? So that would give me 7 even numbered floors. Okay, good. Okay, so from our previous question, we know there are 200 guest rooms on number floors. Then we know there are 7 even number floors and 28 numbers on even numbered floors, 28 rooms on even numbered floors. Good. Okay. And how did you put that together into your answer?
Then I just added the 200 by the total, which I have now forgotten.
Okay. So what's the next step after having 207 and 28? Who's messaging me?
So the 200. So you do 7 times 28, which is 196. Yes.
Good. Mm-hmm.
And then add that by 200.
Mm-hmm. Which is?
Which is 396.
Good. Okay. Once I have the number of the answer, do you remember what I said? What should we do?
The 3 dot symbol.
Yeah, so what does that 3 dot symbol mean?
Therefore.
Okay, so I can't type the symbol on my keyboard, so I'm just going to write therefore.
There are 396 rooms in this hotel.
Good. There are 396 rooms in the hotel. Oops. Okay, great job. Okay, so it's great that you guys can get the answer. Remember, do get in the habit of showing your work, right? Especially since sometimes if you make a mistake halfway through, right? If you just have one answer, you can't even go back and fix it, right? So get in the habit of showing your work. Okay, great job in getting the answer. That is the correct answer. So you can see that's basically the steps that I did, right? And then we have 396 guest rooms in the hotel. So great job. Okay, so we have next question. How many cleaners are required to clean all guest rooms, assuming the hotel was full the previous night? Okay, I'm just gonna go back to the problem again because the information is there, right? So we are looking at question E. How many cleaners are required to clean all guest rooms, assuming the hotel was full the previous night? So why do you think the question specifies assuming the hotel was full the previous night? Is it important to say that? Jerry?
Personally, I think it's important because even though there's that many rooms available, sometimes there might not be like residents in every single one of the rooms. So specifying that it's full states that all of the rooms are filled instead of just like a few of them.
Exactly. Great explanation. Great. Do you want to take a shot at answering the question? Or does somebody else want to? Okay. Why don't you take the stage, Jerry?
So we know that there's 396 rooms in total, and then the cleaner can clean 12 guest rooms per like at 12 guest rooms at a time each day for 4 hours. So it would be 396 divided by 12. And then you'll get the answer.
Yes.
So
Okay.
396 divided by 12, I think would be 53.
You're very close. Why don't we try to do a little long division? You guys, I don't know if you guys probably use your calculator all the time. Let's do a little bit of long division. Okay, so 300, do you know how to do long division? I assume you do.
I do.
Okay, somebody walk me through this long division. What should I do?
So you first take the 3 and 9 of the 396 and divide. So you're gonna take that and transform it into 39 and divide it by 12.
Very good.
But there's gonna be a remainder of 3.
What am I putting up here?
3. Because 36 is the closest number that fits to 39.
Good.
6.
And then
And then you end up with 3, and then you put the 6 behind the 3 and divide that by 12 again, and you end up with 3. So the answer is 33.
Very good. So how should I answer the question in full?
Therefore, how many cleaners are required to clean all guest rooms? I don't know. I don't know how to say it.
You can do it. Just try your best. Nope.
Therefore, 33 cleaners are required to clean all guest rooms, assuming the hotel was full the previous night.
Very good. Yes. Great. Okay. So you don't have to say that whole thing. Don't worry. Okay. You can just say something like, therefore 33 cleaners are required to clean all the guest rooms. Okay. So great job, guys. Okay. So let's take a look at the last question. Okay. What is the total cost of hiring the cleaners to
Teacher probably has some internet issue. Just one sec.
Okay, sorry about that. Okay, so last question. What is the total cost of hiring the cleaners to clean the guest rooms of the hotel? Okay, and then keep in mind that for the previous question, we got 32 cleaners. 33 cleaners. I mean. All right, so who wants to answer this question, last question from this problem? Okay, Eric?
It says each cleaner is paid at a rate of 16 euros per hour.
Yep.
So then there are 30, and they have to work 4 hours each day. It says there are 33 cleaners, so I think we multiply that by 4, which we end up with 33. Oh, wait. Give me a second. I need to think. 12, 132, I think.
33 times 4. 132, yeah.
And then we have to multiply it by 16. So 132 multiplied by 16 is give me a second. I need a 132 times 16 to 1. Is it 2,112?
Sorry, say that again. Is it 2,000?
112?
It is, yeah. Great job. Okay, good. And then don't forget, right, my therefore statement, okay, the total cost of hiring the cleaners, clean guest rooms, and then it's euros, right? So make sure you're putting the euro symbol. Okay, so great job for answering this question, guys. And I hope you remember, with any type of multi-step problem, okay, remembering things like showing your work, keeping track of units, putting therefore statements, breaking down the question into smaller steps. Okay. And you guys are doing great. Okay, so any questions about this problem or anything else that we talked about so far?
So your parents' way of waking you up is just taking the sheet off. So everyone will be awake, huh?
My dad wakes up earlier, so he leaves to work before he wakes me. And I wake up before my mom for school.
Oh, sorry, I'm gonna just mute you for a second. Okay, so let's go to the next part. Okay, so this was an opening problem, right? So it's basically meant to get your brain juices flowing. Okay, let's get to a part of the lesson. Okay, so this part of the lesson is indices or powers. So you're probably more used to the word powers, or exponents, but in the book they call it indices or index. So I'm just going to use that wording. Okay, so this is index notation. How many people have learned about powers already? You guys should have learned about them.
I did.
Okay, Anthony did. Anyone else?
I did as well.
Okay,
I
Jerry did. Plus who Lyria did. Eric did. Okay, good. I don't know if the rest of you didn't or you're not raising your hand. All right, so let's take a look at index notation. Okay, so again, just get used to that wording. All right, so a convenient way to write a product of identical numbers is to use index notation. For example, instead of writing 7 times 7 times 7 times 7, we can use 7 to the power, we can write 7 to the power 4. In 7 to the power 4, the 7 is called the base number and the 4 is called the index or power or exponent. And the index is the number of times the base number appears in the product. Okay, so make sure that you're reading this properly, right? We read this as 7 to the power 4, okay? And then this, so the 4 is the index or power or exponent. Okay, really, we call it the exponent generally, but the book often says index. So I just want you guys to get used to the wording. Then the 7 is the base number or just the base. Okay, so anytime we are reading a power, okay, we say the base, okay, to the power of the exponent. Okay, and then we have some specific names when the exponent is 2 and when the exponent is 3. Okay, so instead of saying something like 7 to the power of 2, okay, does anybody else know what we usually say? Jerry, do you know?
7 times 2? I mean, 7 times 7?
So 7 to the power of 2 is 7 times 7, right? But like usually, what do we call it? Like when we name it, when we say it, right? We don't say 7 to the power of 2 to express this power usually. What do we say? Anybody else?
Could you please repeat the question again?
Sure. So I've been saying usually when we say the name of the power, right? So when we're talking, okay, we call the power whatever the base number is to the power of whatever the exponent is. So we read this as 7 to the power of 4, right? But when the exponent is 2, like over here, we usually don't say 7 to the power of 2, right? What do we say? Anthony, do you have an answer?
It is 49.
It is 49. That's the value, but that's not my question. My question is what do you call this power? Eric?
Squared.
Very good. What squared?
7 squared.
Yes, good. 7 squared. Why do you think we call it that?
I don't really know actually.
Okay. Anthony, do you have an idea?
This is just a guess, but I'm assuming this because to find the area of a square, you have to do the 2 of the sides times like multiplied together, and to find the square of this number, it's just the same number multiplied together as, and the square is the same number multiplied together.
Yeah, very good. Exactly. Right. So if I have a square with a side length of 7, to find the area, I would square the side length. I would square the 7, which is the same as this power here. So that's why we say 7 squared. Very good. Okay, so very similar principle, right? What do I call 7 to the power of 3? Okay, so don't give me the answer. Don't tell me 7 times 7 times 7. Okay, just like 7 squared, what is this name? Jerry?
7 cubed.
Very good. And why?
I think it's because a cube is 3-dimensional. So it's gonna be one side times one side times one side, which is, I'm pretty sure, also the formula of finding the volume for a cube.
Yes, good. So finding the volume for a cube. Okay, what is it? Okay, thank you, Anthony. Yes, so finding the volume for a cube, right? If I have a cube, then the extra dimension, the height, it would also be a 7, right? So I would be doing 7 times 7 or 7 cubed. So yeah, that's why we say cubed. Okay, so this is just squared for power of 2 and cubed for power of 3. For other powers, including 1, okay, we say this form, right? The base to the power of the exponent. Okay, so also one more question, since I did bring up the power of 1. What is 7 to the power of 1? Anthony?
Is it just 7 times 0?
So it's not 7 times 0, right? Be careful, because
Or is it just
powers
7?
are repeated multiplication. Is your answer 7?
No, like just 7 times, like the answer is 7, and it's just 7
Yes,
times
the answer
1.
is 7. It's not exactly 7 times 1. The idea is that it's 7. It's just itself, right? So any number to the exponent 1 will always give me the number itself back. Okay, so remember that, everyone. And please, please, please do be careful. Do not confuse exponents with multiplication. Okay, so I always get someone who tells me 7 squared is 14 because they're doing 7 times 2 instead of 7 to the power of 2. So please, please, please be careful with that. Okay, exponents are repeated multiplication. They're not the base multiplied by the exponent. Okay, any questions so far about what we talked about? Okay, no. So let's go into the next slide. So we have some different forms, okay, and how to express them in their names. Okay, so following table demonstrates correct language when talking about index notation. Okay, so we have natural numbers. So when we say a natural number, we basically mean the number, the basic numeral form that we're used to. Okay, and then when we have factorized form, okay, we express it as repeated multiplication. Okay, so for 3, it will be the same thing, right? Because there's only one factor. For 9, it will be 3 times 3, right? So for 27, it will be 3 times 3 times 3. So we're seeing the repeated multiplication. Okay, then index form, okay, or sometimes you might see this called like just, as a power. Okay, we have 3 to the power of 1, for instance, for 3, 3 to the power of 2, 3 to the power of 3, 3 to the power of 4, 3 to the power of 5, right? Or 3 squared, 3 cubed. Then we have the spoken form, right? So this is what I mean. This is how we say it, okay, or how we read it. So 3, obvious, right? 3 squared, 3 cubed, 3 to the 4th, 3 to the 5th, or you could say 3 to the power of 4, 3 to the power of 5. Okay, so this is just showing the different forms when we have index notation. So make sure you're familiar with both the name of the form and the form itself, right? So if I tell you express this in factorized form, make sure you understand what that's asking for, right? If I say if I give it to you in index form and ask you in spoken form or in natural number form, okay, make sure you understand what that's talking about. And you are allowed to use a calculator, okay? Because on your test, you'll be allowed to use a calculator. But if it's possible, try to do it mentally, or even like long multiplication or long division, because it sometimes actually saves time and it's good for your brain. Okay, somebody's very happy that you're allowed to use a calculator. Okay, Okay, but use the calculator up here. There's a great calculator up here that you can use. All right, any questions so far? No? Okay. So let's just do a couple of questions. Okay. So we have number 1, write each number in index form. Okay. So A, okay, who wants to give A a shot? Okay, Eric. All right. So, well, how should I write it?
3 to the power of 4.
3 to the power of 4. Good. Do you know what that is?
81.
Yes, very good. Do you know how I can express that as a power with a different base?
With a different base, 9 to the power of 2.
Good. Okay, this is not part of the question. I'm just extending. Okay. Question B, 5 times 5 times 5. Anyone? Okay, sorry, let me just. Jerry?
5 to the power of 3.
Okay, good. What's that usually said as?
That's usually said as 125.
Oh no, I mean, what is the spoken form?
5 cubed.
Okay, and again, the value is not necessary in this question. I'm just expanding a little bit, so good job. All right, and for C, I think Anthony raised your hand, so do you want to try for C? Keep in mind there are two different.
It's 4 to the power of 2 times 7 to the power of 4.
Good. And how do I usually say 4 to the power of 2?
4 to the power of 2 is equivalent to 4. Wait, no, not cube. Squared. Yes.
Okay, good. And what's the answer? Tell me in 5 seconds.
Unable to process.
I'm joking. I don't know. I can't do this in my head. Okay. Good. That's good. Okay, so yeah, don't be daunted if you see more than one number. We're basically just expressing it as multiplication of powers with different bases, and make sure that you're not trying to write this as one thing. Okay, that doesn't work. All right, let's look at number 2. Okay, convert each product into natural number form. Okay, so 2a, 2 times 3 times 5. Okay, when we say natural number form, that's like a very fancy way of basically saying evaluate the expression, right? Okay, who raised their hand? Eric?
30.
Good. Okay. No, so very straightforward here, no tricks here, all right? B? Jerry?
Me?
Sorry?
20.
Yes, good, 20. Okay, so if you want to break down to steps, right? We have, it's 4, that's a very ugly 4, sorry. Okay, it's 4 times 5, which is 20. Okay, and then C. Well, 3 people raised their hands. Great. Okay, Kiki, why don't you give this a shot? New participants, wonderful.
90.
90, very good. And can you just tell me step by step how did you get that?
I did the 3 squared first, that equals 9, and then 2 times 5 equals 10, and then 10 times 9 equals 90.
That's very good. Okay. Okay, somebody's going a little wild in the chat here. What's happening? Okay, so you just I would prefer for you to raise your hand and just answer verbally. Okay, that way that everybody can also keep track. Right, so let's not go crazy, not go crazy with the chat, but appreciate the enthusiasm about participating. Very good. Okay, Okay, good job. Now for number 3, okay, now I want you to write the following index form with 2 as a base. All right, so keep in mind 2 as a base. Shania, is that how you say your name? I saw you raise your hand earlier, so do you want to give this a try?
I'm not sure I get it though. Index.
Index form? Okay, let's take a look. Let's take a look at the table again. Okay, I'm gonna clear this. Oh, okay. All right, so this is what we mean by index form, right? So basically just you're expressing it as a power, okay? And then remember when we say a base of 2, right, we mean that this number here, this has to be a 2. So you're thinking in repeated multiplication using 2. How many times do I multiply 2 to get this given number? Okay, and then remember I pronounce it as 2 to the power of whatever the exponent is. Okay, so can you try with 2?
All right. 2 to the power of 1.
Yeah, very good. 2 to the power of 1. Okay, B16. Okay, I couldn't. Okay, just raise your hand if you're already raising your hand. Okay, Anthony.
It is 2 to the power. Wait, no. 2 to the power of 16.
It's 2 to the power of 16?
Yes. Wait, no.
Sure about that?
Isn't it 2 at the base?
Yes. 2.
Sorry. I did this. Oh, nuts.
It's okay. It's okay. Take your time.
2 to the power of 4?
Yes.
No, yes, 4.
Yes. Yeah. Right. How would you double check that?
So just divide 16 by 2.
And it will give me 4?
No, divide 16 by 2 is 8.
Okay.
Divide by and then divide 8 by 2, which is 4, and divide 4 by 2, which is 2, and then divide 2 by 2, which is something.
And yes, okay. Eric, did you want to add something?
No, I just wanted to answer the next question.
Okay, so just hold off on that for a second. All right, so if you need to check this, right, 2 to the power 4 means 2 multiplied by itself 4 times, right? So use expanded form and double check that it does give me 16, which it does. All right, so you wanted to answer the next question? Go ahead. What's the answer?
I think it is 2 to the power of 6.
2 to the power 6. Okay, and how would I double check that?
Either you could do, there's 2 ways. You could do 2 times 2 times 2 times 2, etc., or do 64 divided by 2 6 times.
Yes, that's good. And you're right. It is 2 to the power 6. I'm going to give you a little challenge. Can you tell me, okay, who is the one? Okay, Jeremy, thank you for answering. Hold off a second. Okay, are there any other bases that I can express 24 as index form? Anthony?
4A, right?
No.
Oh.
We're still carrying on for 3C. Okay, so guys, I appreciate you really want to answer all the questions, but please do pay attention to what I'm saying right now, because we might keep talking about a question, right? So, but if you're just like, oh, I must answer for A, B, C, D, F, G, you're gonna miss what I'm saying, and you're gonna miss part of the lesson, right? So don't rush ahead, focus on what we're talking about right now. Okay, so my question is, 64 can be expressed as 2 to the power 6, which is what this question is asking for, but can it be expressed with any other base? Okay, Eric?
8 to the power of 2, and there's 1.
Wait. Hold on. Okay, so you said 8 to the power of 2. Good. That's very good. Okay, I just cut you off because I want to see if anybody else could give me another one, but thank you very much. Okay, Jerry, you also raised your hand. Did you have the same answer or a different answer?
I was about to say the same answer.
Okay, okay, so anybody else have a different answer? Kiki, do you have another answer?
4 to the power of 3?
Yes, very good. 4 to the power of 3. Okay, so 64 can be expressed 3 different, well, it can also be expressed as 64 to the power of 1, but we're going to ignore that, right? So it can be expressed 3 different ways to the power 6, 8 to the power 2, 4 to the power 3. Okay, so very good. Now, for number 4, write the following in index form with 10 as a base. Right? So please read the whole answer for me. Okay, so for instance, if I was answering 3b, I would say 16 equals 2 to the power of 4. Okay, so read it as a whole sentence like that. Okay, Jeremy, you've been answering the chat very enthusiastically. How about you say the answer for us for 4a? Or do you only talk in the chat? Can you say it out loud, please? Jeremy? You don't have a mic? You don't have a mic. Okay, so Jeremy, okay, that's okay. Jeremy said 1 to the power of 2? Oh. So 100 is 1 to the power of 2? You sure about that? What is it? I think you meant to say 10. Okay, I think, right, you meant to say 10 to the power of 2. Yes, okay. Yes, yeah, 100 is 10 to the power of 2 or 10 squared. How about for B? Who wants to give that a shot? Shania? Go ahead, Shania.
10 to the power of 5.
How do you read this number? Remember I said, can you read the whole answer starting with the number itself and then say equals
100,000.
Good.
It would be 10 to
And
the
you said
power
it's 10 to the power
of 5, maybe?
Yes, yeah, it is 10 to the power of 5. Good. And the last question. Let's see who raised their hand. Anthony?
Is it 10 to the power of 6?
Can you read the number, the original number as well, please?
1 million.
Very good. It is 10 to the power of 6.
I would like that much money.
Wouldn't we all? Okay, so who can tell me, like, when it comes to base 10 powers, right? So powers of the base of 10, what's the relationship between the number of zeros and the exponent? Sorry, is the question not clear? So I mean, okay, when you have numbers that are powers of 10, right? So like these numbers, okay, what's the relationship between the number of zeros in the natural number, okay, and the exponent in the index form? Let's see. Jerry?
As long as the base number is 10, the exponent should be the number of zeros inside of the neutral number.
Wait, sorry, can you, that was a little confusing. Can you say that again?
So as long as the base number is 10, the exponent should be the number of zeros inside of the number.
The exponent should be the number of, okay.
So like if there's 2 zeros, then the exponent should be 2.
Yes. Okay, so the number of zeros in the natural number is equal to the exponent. That's what you mean, right? Good. And be careful. Okay, it's natural number, not neutral number. Okay, so just be careful about that wording. Okay, so good job for this question. Good job for these questions so far. Any questions about indices? No? Okay, so let's just look at the chart again, just to make sure you guys are remembering these. All right, we say the natural number. Okay, so this is a very specific category of number that will come up more when we talk about number sets. Okay, but just so you know, natural numbers are what we colloquially call whole numbers, right? So no fractions, no decimals, 1 and greater. Okay, so when we are talking about powers so far, Okay, these are the numbers that we would use for the base, okay, or for the exponent. Then we have factorized form, right? Sometimes called expanded form because it's expanded multiplication. Okay, and then we have index form, right? Sometimes it's just called expressed as a power. Okay, and then we have spoken form, so that's how we say it. Okay, so just keep in mind the squared and the cubed exceptions. Okay, then let's keep going. Does somebody have a question for me? 100 to the power of 3. Okay, so Jerry asked, for 4C, is 100 to the power of 3 another answer? Good question. I like that question. Okay, I'm going to put it up here. So I want to see if anybody has an answer to this question for 4C. Okay, so is 100 to the power of 3 another answer for 100,000? Anybody have an answer for me? Shania, what do you think?
I think so. I'm not sure, but I think so because if you do 100 times 100, it equals 10,000. And then that times 100, just add 2 zeros to it. Then you have 1,000,000. So I think that's okay to do.
Okay, so I have one yes. Anthony, what do you think?
It's yes.
Okay, you also said yes. I think I saw somebody else raise their hand, but then I lost them. Eric, was it you who raised your hand?
Yeah.
Okay, what's your answer?
Yes.
Okay, so I have 3 yeses. So disappointingly, now I feel disappointed. The answer is no. Okay, and the answer is not no because you're wrong. Okay, so it's not because 100 to the power of 3 is not 1,000,000, but look at question 4. Right, what does question 4 say? Write the following index form with what as a base? 10, right? So this question very specifically asks you to write it with 10 as a base. So no, you cannot write it with 100 as the base. Okay, but you're right that 100 to the power of 3 is 1,000,000. So very careful because you could be right, but it's not what the question is asking for. So in that sense, you're wrong. Okay, I also feel like I might have confused you guys because for question 3, I was challenging you to express the number with a different base. So sorry if I confused you. Okay, when we're just looking at the question, its specific requirements, this does not follow the specific requirements. So no. Is that okay, Jerry? Can't see you. Can you raise your hand if it's okay? Okay. Okay. Shania, did you want to say something?
Yeah, I have a question.
Uh-huh.
So we all know the bed mass, right? Or like PEDMAS, like parentheses, exponents, division, multiplication, addition, and subtraction, right?
Yes, I hope you guys all know BEDMAS, yes.
So do we have to always do like exponents second if there's like a parentheses there?
So can you give me an example?
Like, for example, you have to solve a math equation, a sentence, and then you have parentheses in it, and you also have exponents in it.
Okay, so do you mean something like where the base, like let's say I have 5 plus 3 squared here, okay? Like, do I have to do the 5 plus 3 before I square it? Is that what you mean? Yes, I have to. Yes, I have to do brackets or parentheses first. So I have to do the 5 plus 3 first, which is 8, right? And then I square it, okay? And then I get 64. Okay, you can't, if you can't do like, if the brackets were not there, right? Then you would have like 5 plus 3 squared, right? So it would be 5 plus 9, it would be 14. It would be a very different answer. It's also not equal to 5 squared plus 3 squared. Okay, so yeah, you have to do, you always have to do brackets first. That's why they're at the top of BEDMAS. Is that okay? Yeah? Okay, good question. Please feel free to ask questions, guys. Okay, Then we have a final question. Oh, where can't I? Okay, so write the following in exponent form, okay, and I have three numbers, and if you have more than one answer, feel free to say it, but let's just not say anything to the power of 1, okay? So we're not going to say that because you can apply that to everything. All right, so Shania, you raised your hand. You want to answer A?
Okay, first, is the base 16?
There's no restrictions on the base except for what I just said. Don't answer with the base as the number itself. Okay, so you don't say 16 to the power of 1.
Oh, so I would say 4 to the power of 2.
Good. Which I usually say as what? How do I
4 squared, sorry.
No, it's fine. You weren't wrong. I just want to make sure you still remember that. Okay, good. And Eric, you also raised your hand. Did you have a different answer?
I had the same one, but now that you mention it, I do have another one.
Okay.
2 to the power of, wait, 4?
Yeah, very good. So I noticed that the base and the exponent are flipped for these, right? Like 4 to the power 2 equals 2 to the power 4. Do you think that's a coincidence or does it always apply? Eric, what do you think? Were you raising your hand to answer that?
Just give me a sec. I think it's just a coincidence.
Okay, so you think it's a coincidence. Anthony, what do you think?
No.
It's not a coincidence? It always applies?
Maybe.
Okay.
Probably.
And you?
Intense central processing.
Okay, and you, Shania? So like, do you guys think that, let's say 7 to the power 3 equals 3 to the power 7?
Yes.
Okay, what if I give, okay, so do you think 10 to the power of 1 equals 1 to the power of 10?
No.
No, but if like you said, it always applies, then it has to always apply, right? Okay.
Right.
Okay, so no, it's just a coincidence, right? Okay, the coincidence occurs because 4 itself is already a power of 2, right? It's a 2 to the second power. So it's basically 4 is 2 2s, right? And then we square that, you end up with 4 2s. So 4 to the power of 2 is 2 to the power of 4, but it's just a coincidence. Okay, and next question is 36. Okay, so we want to think of what's 36 in exponent form. Shania?
Okay. It would be 6 to the power of 2.
Good. And are there any other possibilities?
Yes.
What do you think is another possibility?
It would be 2 to the power of something. I'm not sure.
Why do you think 36 is a power of 2?
Wait, hold on.
Okay.
No, I don't think so.
Okay, so I saw somebody else raise their hand. Who else raised their hand? Eric, was it you?
Yeah, but I had the exact same thing.
Okay, do you think there are any other possible answers?
No.
Okay, good. Yeah, that's it. That's the only thing. Okay, well, we're not counting 36 to the power of 1, right? Good. Okay, then the last question, 125. Okay, so this time we're just gonna choose somebody else who didn't answer the last question or two. All right, Jerry, you haven't answered in a while. Can you give me an answer for 125?
125 would be 5 to the power of 3, or 5 cubed.
Very good. Are there any other possibilities?
I'm not thinking of any.
Okay. you're good. Okay, that's the only possibility. I just like to ask you guys that to make you think about it. Okay, so don't worry, be like, oh my god, she said there's another possibility. All right, so like to trip you up a little bit, keep you on your toes. Okay, so now I'm going to just give you a question right now involving some, okay, what is Anthony saying? Oh, you're a little comedian. I was gonna say stand-up comedian. You're a little sit-down comedian, huh? Okay, I'm gonna give you guys just a question, a BEDMAS question involving some powers, right? You just solve it on your own, and you can let me know in the chat if you want. Okay, so everybody, might have different speeds when they're solving. So maybe just say in the chat so you don't give it away for people who are still solving it, right? Okay, so let me just start. I'm just writing with my mouse, so it's like a little ugly. Let's make it a little bit bigger. So I hope you guys have some paper or something to write with, unless you can all do them mentally, which I would be very impressed by. Okay. Let's just, won't make it too long. Okay, let's just leave it here. All right. So, okay, 3 squared minus u cubed to the power 6 plus 4 cubed minus 7 squared. No calculators. And then if you have the answer, you can just type it in the chat. Use the direct message just to me. Okay. Or if you have any questions about the question, feel free to ask.
I have a question.
Yes.
In this particular case, like I asked, the parentheses always comes first, right?
Yes, in every case, parentheses always come first. Or
so then what would you do? 3 minus 2 equals 1. Then you already have those.
Sorry, 3 minus 2 equals 1? Why am I doing 3 minus 2? Okay, let me just highlight. Okay, so I have one correct answer and one incorrect answer. Okay, so far Eric and Anthony have answered. Anybody else from please send me a chat once you have the answer or what you think is the answer. All right. Oh, I just noticed it's getting a little late. Okay, so let's take this up. Okay, so remember, you're evaluating within the bracket first, right? 3 to the power 2, 3 times 3 is 9. 2 to the power 3 is 2 times 2 times 2, it's 8. Okay, so 9 minus 8, right? All to the power 6. Okay, I'm going to just keep solving this step before I move on to the rest. Okay, so that's 9 minus 8 is 1, right? 1 to the power 6 is 1. Right, so anything to the power of 1 to the power of anything is always 1 because 1 multiplied by itself any number of times is still 1. Right? Then I have 1 plus 4 to the power of 3. Okay, actually, I'm going to just 4 to the power of 3 is 64. Okay, 4 times 4 times 4. 7 to the power of 2 is 49. Right? Then 64 minus 49 is 15. Right? And then I have the 1 from before, so 1 plus 15 is 16. Okay, so your final answer is 16. Okay. Okay. Does that make sense? I tried to pick slightly smaller powers so you could do it mentally or on paper if you need to.
But
okay. All right. So that's the last question. Okay. Okay. So great job, everyone. Good work today. Hope you asked questions if you were unclear about something. And this is, the end of the class. So if you guys have any questions right now, please do ask. Anybody? Or you can ask in the chat as well.
I saw still there are two hands raised. One's Anthony. Anthony, Shania, you have questions?
I forgot to lower it.
Oh, okay. I'll lower for you. Good job, Anthony, today. Shania actually is Sherry. Shania is your sister. I know that's Sherry.
Yeah, I couldn't change my name.
That's fine. Don't worry. Sherry, question?
Yeah.
Go ahead.
Yes, my question is, what exactly is the Pythagorean theorem basic? Like, how do you do the Pythagorean theorem?
The Pythagorean theorem?
Yes.
Well, we don't have enough time in class to go over that. That will be a lesson, so don't worry, you'll learn that one day. Is it basic? I'm not sure what you mean by basic. I believe that's introduced in the curriculum in grade 7, right? So, or is it grade 8? Okay, so don't worry, we will definitely learn that, but we don't have time to talk about it today. Okay?
I think probably